Okay, so the last bit of trig, this is really just yesterday but with a calculator. So solving trig equations with non-exact solutions. Okay, same deal, and that takes us back to the early days of trig, which seems so long ago now. Back when you didn't know what a radian was. Round all values to the nearest hundredth of a radian or the nearest degree. Okay. So 3 sine theta plus 2 equals 0. From 0 to 2 pi, not including the 0. Right? Now that would only matter if 0 were a solution and you were to state it as a solution, because in this restricted domain it wouldn't be. Okay, so you like lose a little half mark. So you really have to pay attention to these. Does it include the 0 or the 2 pi or both? In this case it's not going to matter because the solution to this is neither 0 nor 2 pi. So 3 sine theta is negative 2, and sine theta is negative 2/3. And now we're back like 50 lessons ago, right? Just sine theta is negative 2/3. So you say, well, it's in quadrant 4. So where is it? Quadrant 3 or quadrant 4? Okay, so the sine ratio is negative. The reference angle is the inverse sine of positive 2/3. Okay? So anytime we do a reference angle, it's always of the positive ratio. Okay, that thing's not noisy. You can crank away on it. You don't have to be quiet. It's not of the... Okay, so got to be in radians, right? And so mode's going to be flipping back and forth a lot, right? So sine inverse of 2/3 is 0.73, so rounded to 0.73. So theta reference is 0.73, and we need that angle in quadrant 3 and in quadrant 4. So my two angles are pi plus 0.73, which is, okay, I mean, we can be exact here, right? We can just use that number. So we just go plus pi. Where's the pi? There it is. 3.87. Okay. Now, if you're rounding, you want the calculator to do the rounding for you, just go to mode, set it to 2 decimals. It'll round for you. So 3.87. And theta is equal to, what's the other one? 2 pi minus 0.73. Okay, and again, so I'm just going to go 2 pi minus, and I'm just going to go up and grab this number. Now, if you're on a calculator that you can't grab that number, you could store it. And, so 5.55. Okay, so that's our two angles. Theta. So if you want, theta could be the set consisting of 3.87, 5.55. Right, and you can write rads after that if you like, or not. Remember, the one thing to really watch out for is if it's in degrees, make sure there's a degree symbol. 5 cos squared x minus 7 cos x plus 2, 0 to 360. What are we going to do for this one? So we're going to have to factor, right? It's a quadratic in cos x. So one of the factors will be 5 cos x, and the other one will be cos x. And it's equal to 0, right? Like, don't just factor it and leave off the equal 0. Equal 0 is important. Allows us to actually solve. All right, how are we going to get a 7 out of this? 2 and 1. Well, just a 1 and a 2, right? A 1 and a 2. A 1 and a 2. So 5 cos squared minus 5 minus 2 minus plus 2, yeah. Right. Hopefully by now factoring is relatively easy. But always check. It's easy to mix up the signs. You do that and then everything here goes wrong, which probably would cost you half a mark, right, because you're still solving. But if you turn it into something, you factor it wrong such that now you don't have any solution, well, first off, you could graph this and see that there are solutions, right? So that's one thing. I mean, you can certainly check your answers, right? We're going to get 2 answers. So you can graph this from 0 to 360, calculate it in degree mode, and see what the solutions are. So here we have 5 cos x minus 2 is equal to 0. So 5 cos x is 2, and cos x is 2/5. And here we've got cos x minus 1 is 0, so cos x is 1. Okay, so we know that, right? That's 0 degrees. Oh, but it's not 0 degrees, so what is it? It's 360 degrees. Okay, so you solve for cos, right? And the way I solve for cos, I just think if it's a 0 or a 1 or a -1, I just draw the cos and say, oh, okay, it's 1. Oh, wait, but we're not doing 0, so 360. Okay, and cos x is 2/5. Which quadrants? 1 and 4. What's my reference angle? So x ref will be the inverse cos of 2/5 in degrees, so mode degrees. This time we're rounding to the nearest whole number. You could go float, set it to a 0. If you do that, you can mess yourself up in subsequent calculations. So just keep in mind, if things don't look right, go check and see if you did rounding. So what are we doing? The cos inverse of 2/5. And we get 66.4 degrees, but we're just rounding to the nearest degree. So I need 66 degrees in quadrant 1, that's pretty easy, and in quadrant 4. Okay, so what's x? So in quadrant 1, it's 66 degrees. Don't forget the degree symbol, otherwise you're writing radians, right? And you don't want to do that. What's the other one? So it's going to be 360 minus, and I could just pull that number down if I want, but it's still going to work out the same. 293.6, so 294 degrees. And that's it, right? Ah, you say, but what about the 360? Okay. Did that on purpose. That's one of the few. Yeah, don't forget the 360 degrees. Okay, so 3 solutions. And again, if you've got time, test is over, you're done, and go graph it. 0 to 360, right? Look, put a scale of 60. You'll see something a little past the first tick. You'll see something a little shy of the 5th tick, and you'll see something on the 6th tick. Okay, so it means your window should be a little bigger than 0 to 360, just so you can see that. Okay? Questions? X belongs to the real in radians. Okay, same deal. So what are you going to do? What's the first step? Stick it all on one side, right? So it's a quadratic. It's a quadratic in sine x. Okay. If you don't like that, just let a be sine x and write 8a squared minus 2a minus 3 equals 0. Factor that. Then replace the a with the sine x. Right? It's George Polya, a very mathematician. Right? It's just solving a simpler problem. I don't like these sine squares. Then don't deal with it. Okay, so first step, 8 minus 2 sine x. Okay. Again, this is checkable by graphing, right? Calculator in radian mode. Go 0 to 2 pi, right? It's just to see your first bit. What's it going to be? 4 and 2 probably? 4, 2, 2, 3, 4, 12, or 6. Maybe 12. Minus 3 and 2 Okay, 8 plus 4 minus, yeah, nice. Yep. Always make sure you check, right? It's not like grade 10 where factoring, hey, I factored, great, it's over. Right? It's like factoring, oh, and now we keep going. So make sure you've got the equals 0. You can't solve it unless it's equal to something, right? There's no values of x if you don't write equal to. So 4 sine x is equal to 3. And sine x is 3/4. Okay, and that has a solution, right? Because it's if sine x were like -2, then we'd say, well, you're done, right? There's no solution to that. Okay, because sine and cosine have to be between -1 and 1, right? So if you get like cos x equals 3, like we did yesterday, you put an x underneath it, so done. And 2 sine x. So 2 sine x. Okay. Hey, those are exact values, so I can do them as exact, but when I go to state the answer, I'm going to convert them into radians, rounded to the nearest hundredth. Okay, because that's what it's asking for. So even though I know the exact values for these, right, which is what, 7 and 11 pi over 6, right, 7 pi over 6, 11, I'm going to have to convert those into radians to the nearest hundredth. Okay, which means really I could just do an inverse sine on a half, and then I don't know what's easier. Okay, so this is quadrant 1 and 2. X ref, my reference angle for x, is the inverse sine of 3/4. And we're in radians, so we got to go back and. Now, here's the thing. If you're in radians when you should be in degrees, you should recognize it because you're going to get very small angles, right? Remember, 6 radians is, 6.28 radians is once around the circle. So when you're doing this and it's like comes out, oh, the angle is 0.72, you're not in degrees, right? You're in radians. There's no way that you're getting that. 0.72 is like, no angle. It's like 0. Like, it's so close. Okay, what do we want? Inverse sine of 3/4. 0.85. I'm going to go with 0.85. Okay, and here, this is Q3 and QIV. And x ref is equal to pi over 6, and x is 7 pi over 6 and 11 pi over 6. Well, I don't have these angles yet. So x here is 0.85, and in quadrant 2 it's going to be pi minus 0.85. Okay, so we got to get our. So pi minus, I can just bring down that number. So 2.29. I like the flashing lights and the 7 pi over 6, or do the inverse side. So here's 7 pi over 6. 7 pi divided by 6. 7e, say, okay, never mind. 7 pi divided by, I hate this calculator. Okay, 3.66. Now you could also do this, right? Go sine inverse of 1/2. Okay, is 0.52, but it's in quadrant 3, so it's going to be pi plus that. Second pi plus, which should come out to this, right? 3.66, 3.67. So 3.67. And I can go 2 pi minus, so it's also quadrant 4, right? 2 pi minus this number here, 5.76. Okay, so if it were 0 to 2 pi, we're done, but it's not. Okay, so now we got to write out basically 4 statements, right? 0.85 plus 2n pi, 2.29 plus 2n pi, 3.67 plus 2n pi, and 5.76 plus 2n pi, where n belongs to the integers. And don't forget the n belongs to the integer, right? You gotta make that statement. You can't just throw an n in there. Okay? So, like yesterday, right? Only less exact. Well, except this one. This was exact. But you gotta turn it into decimals, right? So these would be, I mean, it's a very nice numerical response question, right? What's this value? Or the largest value between 0 and 2 pi is, or the smallest value between 0 and 2 pi is, rounded to the nearest hundredth of a radian, because that would fit very nicely in the 4 boxes. Cotan squared. Okay, so cotan squared theta is 5. So what's cotan theta? Plus or minus. Yeah, that's the key, right? So when we're square rooting, it's plus or minus, right? So cotan theta is plus or minus root 5. Where's the inverse cotan key? No, we don't have one, so what do we have to do? What's tan theta? Plus or minus 1 over root 5. If you like, you could write root 5 over 5. Okay? I don't think you need to, right? Because we're just going to find the angle. So really, you know, it doesn't matter. Okay, so what's theta ref? Oh, so first off, we're in all quadrants, right? Okay, so if tangent is positive or negative, it's Q1, Q2, Q3, Q4. Bless you. Theta ref is the inverse tan of 1 over root 5. What are we in? Degrees. Mode. Degrees. So all that review stuff is up. You could just like do nothing but math this weekend, right? Like you could get home today and just solidly go through the weekend doing all of the review stuff and all of the... One hint for you, when you're working with identities, give it a shot. If it doesn't go anywhere in a couple of minutes, leave it and come back to it later. Okay? It's very easy to get sucked into an identity time warp, right? All of a sudden, like 20 minutes is gone, and you know, I've been sitting staring at this identity. So give it a shot, and then coming back to it later, you might recognize something you didn't see the first time. Also, don't erase anything. You could be like half a mark away from the answer and just not realize it, right? Like you just don't see that, oh, you're there. You only have to do this. And you don't see that. So don't erase it, wiping out all the marks. Just leave what's there, okay? But watch out with proving identities and stuff, right? And just practice, 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 practice. Okay, where are we? Oh, I was doing the inverse tan of what? 1 divided by root 5? Root. Okay. I hate this. I do that all the time when things don't work out. So make sure you know how to use your calculator, especially when you've got roots in the thing, that you don't throw stuff in that shouldn't be there. So 24 degrees. All right, so think about it, right? So we got 24, 24, 24, 24, there's 24, there's 24, there's 24, there's 24. So the fancy way is, oh, hey, I remember this, right? It's like plus or minus 24 degrees plus 180, right? And that'll take us all the way around. So theta is equal to plus or minus 24 degrees plus 180 n degrees, where n belongs to the I. Okay. That's the fancy way. Okay. You don't have to get fancy. You could state it, so just theta is 24 degrees. plus 180 n degrees. And theta is, so that takes care of anything along here. And then this angle is 180 minus 24, right, which I think is 156. So theta is 156 degrees plus 180 n degrees. Okay? So if you want to, like, figure these out. That's 24, that's 156, that's 204, and that's 360, 356, 336. So just try that on here. 24 plus 180 gets me 204. Okay, that's good, right? Negative 24 plus 180, that gets me 156. Okay, 156 plus 180, that gets me the 300 and whatever I said it was over there. Right? Like, just make sure you're going to get the right angles out of it if you're trying the fancy stuff. Right? The not so fancy stuff is actually pretty straightforward. Okay? Try not to shoot yourself in the foot. Right? Like giving too much. Oh, you know, restrict the domain. Well, you could do this or that. Wrong. Just, you know, x is greater than a billion. That works. Kind of silly, but it works. A formula for the area of a triangle is given. This, I think it's called Heron's formula. A guy named Heron, not the bird. Is 1/2 AB sine C, where C is the angle of the triangle between sides A and B. In triangle ABC, A is 10.7 centimeters and B is 14.2. If the area of triangle ABC is 40 square centimeters, then determine all possible values for the measure of C to the nearest degree and draw the resulting triangle. Okay. So what's C? If C is an angle in a triangle, it's between what and what? Are we in degrees here? It's got to be degrees, right? Oh, your nearest degree. I mean, really, I don't think we should have the 0 and the 180 in there. It can't be 0 and it can't be 180. Wouldn't be much of a triangle. Okay, so we're looking for an angle C, which we know is between 0 and 180, right? So we have a restriction on the domain based on the context of the problem. It's a triangle, therefore the angle is between. Okay. What do we know? So we know the area is 40. Okay, so we got a formula, 1/2 AB sine C. The area is 40. Little a is 10.7, and little b is 14.2 times the sine of C. So you can see we're going to solve for sine C. Right, and then we're just going to do what we've just been doing. So this will be 80 is equal to, okay, I don't think we need to go into horrendous amounts of detail here. So sine C is going to be equal to 0, okay, what do we got? 80 divided by, and I'm going to bracket this up and go 10.7 times 14.2. I missed the 2. Okay, 0.52652362. So here's what you write here, right? 0.5265 dot dot dot. Right? Just say it keeps going. Okay, we know that we want a quadrant 1 or quadrant 2 angle, right? Because C is between 0 and 180. So Q1 or Q2. Okay, and that matches, right? If that came out as negative, we'd be in trouble. So that can't. So if you got a negative there, you know something's wrong. So what's the reference? C ref. Did it say to the nearest degree? Okay, so what is it? 32 degrees. Okay. So then our angle is 32 degrees, or what? 180 minus 32, so 178 minus 30, 148 degrees. Okay, those are both doable, right? I can make a triangle that's got a 32-degree angle between the sides, and because it asks us to draw them, right? So the area of them to determine all possible values that we have, and draw the resulting triangles. Okay, so we got A and B, and so we got A is 10.7. We'll make something that looks like about 30 degrees. and B is 14.2, and this is 32 degrees. Okay, so there's one triangle, and A is 10.7, 148 degrees, right? So that's 90, so it's going to be like that. So that's 148 degrees, and B is 14.2, it's not degrees. And there's your triangle there. Okay, so two possible triangles, both of which have an area of 40 square centimeters. Right? So I mean, yeah, if you wanted, you could use a whole bunch of other trig to work this out. So Heron figured this out, right? It's sort of based on two sides and angle between. That's kind of a cosine law thing, right? Allows you to get the third side, but then you'd have to figure out the height, just the perpendicular distance here, and go the base times the height. Right? Okay. If you did, it would come out to 40. Exercises. That's for you, but we have one more. Here we go, the final lesson of trig. Solving trig, everybody's favorite thing, identities. Have your orange formula sheet handy. And I don't know if you need a calculator, I guess it depends what they ask. Algebraically solve the following equations for the indicated domain. Write all answers as exact values where possible. Okay. Otherwise round to the nearest hundredth of a radian or the nearest degree. The reason we do that is you can't fit a tenth of a degree into the four boxes on the thing unless it's under 100 degrees. And that would give you a clue, so we wouldn't ask that. That's why we say round it to the nearest degree. That way if it's 1 degree, it goes in the box. If it's 360, it goes in the box. Okay, if we said nearest tenth of a degree, you know that it has to be under 99, right? You couldn't fit it. So, anyway, that's why we say nearest degree. Hundredth of a radian, that fits in the four boxes, as long as we keep the first digit under 10, under 9, 9 or under, which is easy because it only goes to 6.28 radians. Okay, sine 2 theta is equal to 0. There is ways to do this, okay, but they're kind of hard. You could replace the 2 theta with an x, just say sine x is 0 and then cut the x in half. But no, we have identities, right? What's the identity for sine 2 theta? 2 sine theta cos theta is equal to 0. So the idea is we can use identities to simplify the equation. Well, how is that simpler? Well, it's easy. You've got three things multiplied together to give you 0. So the 2 can't be 0. So either sine theta is 0 or cos theta is 0. Okay? So then we say either sine theta is 0 or cos theta is equal to 0. And we should kind of know these, right? Because they come in as the restrictions on domains for secant and cosecant and all that good stuff. So if sine theta is equal to 0, then theta is equal to n pi. Okay. And again, I mean, what you might want to do, what I do is this. Okay, so I've got n pi, and then I've got pi over 2 plus n pi. Where n belongs to the i's. Now wait a sec. Will pi over 2 plus n pi, will that cover these guys too? Let's see, if we went half pi. So if we just did half pi, so we get 0, we get a half pi, we get 1, we get a half, we get a full pi, we get 1.5 pi. We get, yeah, I think we could just do multiples of the pi over. So you could do this, right? Or n pi over 2. Either one is acceptable, right? As long as they're correct, it's acceptable. Okay? So if you don't want to get fancy, here you go. If you want to get fancier, here you go. Okay, so either one, they're both right. Cos squared minus sine squared equals 0. So we need to get it in terms of sine or in terms of cos. So can I replace, well, let's replace the sine squared, right? So let's go cos squared x minus, what's sine squared in terms of cos squared? 1 minus cos squared x, right? Okay, we're looking from 0 to 2 pi, so in radians, probably be exact maybe. So what do we get? Cos squared x minus 1 plus, so we're going to get 2 cos squared x minus 1 is equal to 0. Okay, so now we only have to worry about cosine. We're not worried about sine and cos. So 2 cos squared x is equal to 1. So cos squared x is equal to 1/2. So what's cos x? Plus or minus 1 over root 2, which goes by another name. What's the other name for 1 over root 2? Root 2 over 2. And that's the name that we know it better by, right? So since it's plus or minus, it's going to be pi over 4, right? All the pi over 4s. So x ref is pi over 4. We're in all 4 quadrants, right? Q1 to Q4, so it's in all 4 quadrants. So we have the pi over 4, the 3 pi over 4, the 5 pi over 4, and the 7 pi over 4. So how far apart are these guys? It's like 2 quarters, right? 2 quarters to here, 2 quarters to here, 2 quarters to here, 2 quarters to here. Okay, so that means that x, oh, wait, we're on, damn it, it made for a nice general solution. You could have gone pi over 4 plus n pi over 2, but we don't need a general solution, so we've got the answer. Pi over 4, 3 pi over 4. Okay, so 2 things to remember when you see the square of a trig ratio. One is look on the formula sheet to see if you can find that, right? Somewhere there's a whole lot of places. There's the Pythagorean. There's also the 2 cos squared x minus 1. Right, that's another one, I think, which is equal to cos 2x or something. Which you don't want to do here, okay? Then you'll end up having to go back to this. And the other thing to remember is when cos squared or sine is equal to something, you need a plus or minus. Okay, which means you're going to be in all 4 quadrants, right? The answers. And the other thing to remember is watch the domain. 1 plus 10, what's 1 plus tan squared? Secant. Well, that would be a good thing to do then, right? Because then we got a secant squared here. So secant squared theta is equal to 4 minus secant squared theta. We're going 0 to 360, not including 0 nor 360, right? So what's this become? 2 secant squared thetas is equal to 4. So secant squared theta is equal to 2. So what's secant theta? So secant theta is plus or minus root 2. What's cosine theta? 1 over plus or minus 1 over root 2. Also known as? Okay, and we're going 0 to 360, so 40. We just solved this, right? I mean, if you solve sine theta's root 2 over 2, you also solve cosine theta. So 45, 135, 215, and 45, 135, 225, and 315. Okay, so theta ref is 45 degrees. I mean, sketch it out. It certainly doesn't hurt to draw stuff out. So there's 45, there's a 45, there's a 45, there's a 45. So theta is equal to 45 degrees, 135 degrees, 225 degrees, and 315 degrees. Okay, and that matches up with our 0 to 360. 2 sine x plus 1 is cosecant x. Okay, so what are we going to do with this? What's the only identity that's usable here? Yeah, cosecant is 1 over sine, right? So 2 sine x plus 1. Now, you also have to keep in mind restrictions, right? We haven't run into any restrictions yet, but maybe when we solve this, because the act of solving can introduce things, right? So we know that sine x can't be 0, right? Because then cosecant would be undefined. So we have to keep that in mind, right? 0, 180, 360 in degrees. Not allowable solutions if we get them. So 1 over sine x. Okay, how do we just solve this? First step? Multiply both sides by sine x. So we get 2 sine squared x plus sine x. What's that equal to? 1. Yeah, it didn't go away. So now what? Now we subtract the 1, right? So now we get 2 sine squared x plus sine x minus 1. It's not like, oh, wait, here we go. 2 sine plus sine x. Okay, so that needs to be factored, right? Plus 1 minus 1. Squared plus 2 minus 1. Plus 1. Okay, good. Okay, we're going to be okay, right? Because we're not going to get a sine x is equal to 0, which would be bad for this. But watch for that when you're solving these things, right? Especially when you're looking at the answers and say, well, why don't they have this answer? And it's because, you know. Okay, so 2 sine x is a half, and sine x is negative 1. And we're in degrees, we're doing a general solution, and we're in degrees. Okay, so this is Q1, Q2. This is just x when sine negative 1. 270, right? 270 degrees. And the reference angle here is 30 degrees, so x is 30 degrees, and what's the other one? 150 degrees. Okay, so it's a general solution. So 30 degrees plus 360n, 150 degrees plus 360n, and 270. How far is it from 30 to 150? 120. How far is it from 150 to 270? 120. How far is it from 270 around to 30, which would be 390? 120. Oh, they all differ by 120 degrees, right? Okay, this is perfectly acceptable. Okay, or it's 30 plus 120. Okay, this is perfectly acceptable. Okay. Like, don't say, oh, I've done it, now let me look for this for 5 minutes and not finish the back page or something, right? Like, write this down, be happy, move on. Okay, if you recognize this, great. Tan of 2 theta. Okay, so we don't want to do a tan of 2 theta, right? So what do we have? Damn. I don't know the
2 times x.
2 tan. Where the heck is it on? Oh, okay. Yeah. So 2 tan theta over 1 minus tan squared theta. Okay. All right, 2 tan alpha 1 minus tan squared. Whatever you do, don't put the wrong expression in, right? Because something that would have solved then won't solve, and you'll be staring at it forever. So use the form, right? We give you a formula sheet, please use the formula, even if you think you know it, right? I know this down cold, then look at it and just say, yeah, okay, I do know this. Okay, what are we going to do? What? Cross multiply? Sure, why not? So look, what do we got? 6 tan theta. Now you got to put the negative somewhere, right? Might as well be on the bottom, right? Because it's going to give us negative 4 plus 4 tan squared theta, right? Okay, so negative 4, so we got negative 4 plus 4 tan squared theta, okay, which is going to become 4 tan squared theta minus 6 tan theta minus 4 is equal to 0. What are we doing? 0 to 2 pi, okay. So we're going to factor that. How's that going to go? 4 to 1, 4 and 2 is 8. Yeah. Oh, sure. Actually, that would be a heck of an idea. Divide everything by 2, so what do we get? 2 tan squared theta minus 3 tan theta minus 2 is equal to, that makes life a lot easier, right? So then you got 2 tan theta, and you got a tan theta, and you got a minus 2 and a plus 1. 2 tan squared minus 4 plus minus 3 minus. Yeah, okay. Good idea. If you didn't do it, doesn't matter. You still should get a factorization, and you're just solving the factors, right? So we're just setting them equal to 0, even if you at some point recognize, wow, these are both even. Okay, so 2 tan theta plus 1 is equal to 0. 2 tan theta is negative 1. Tan theta is negative 1/2. Okay, so that's not an exact value, right? So we're going to go to the nearest degree. Okay. Should we solve this one first? Or well, let's just do this. So tan theta equals 2. And that's not an exact value. Okay. So in this case, we're doing the thing. So this is tan is negative quadrant 2 and quadrant 4. Theta ref is the inverse tan of negative 1/2. It's going dark. So mode, degrees, okay. If you're ever in doubt, just go like sine 30. That's all I do, right? What's sine 30? It's a half. So if it's degrees. Okay, so tan inverse negative 1 divided by 2. Don't do that. We do positive.
Would Leon Patel please come to the office? That's Leon Patel to the office, please.
Be positive. It's just going to be 26. 27, right? If we're going to the nearest degree, so theta ref is 27 degrees. Theta ref is 27 degrees, which we need in quadrant 2. So it's going to be 180 minus 27?
No. Yeah.
Yeah. Oh, damn it. So the answer to your question is yes, we are not in radians, but we are supposed to be in radians. Yeah, make sure you do that, right? Because that happens on the test, right? And you're answering in radians when you should be in degrees and vice versa. All right, so I just got to redo this calculation. Got to redo this calculation here. Okay, 0.46, right? Nearest hundred. 0.46. Well, theta is much more difficult now. I like the degrees. I could have done that in my head. So in quadrant 2, what's it going to be? Pi minus 0.46. 2.68. And in quadrant 4, what's it going to be?
2 pi minus 4.
Okay, so let's just bring that back down. Let me throw a 2 in here. 5.82. Tan theta is 2, so it's quadrant 1 and quadrant 3. And theta ref is the inverse tan of 2. How much is it? Somebody got it? Somebody get it? 1.11. So then theta, that's theta ref. So theta is 1.11. Theta is 1.11, and where are we? Q1 and Q3. So what do I do to this? Just add pi, right? 4.25. Was this general or no? Okay, so combine those two together. What do we got? One more? Three cos x is secant squared x. Okay, so what's secant squared? Would that help us? No, because then I got 3 cos there. Okay, so because it just introduces 2 different ratios, right? I still have 2 ratios. What else is secant squared? 1 over cos squared. Okay, so if I do that, then how would I follow that up? So now what? Multiply both sides by cos squared, right? Just keep in mind cos x can't be 0. Okay, what do we get? 3 cos cubed is equal to 1. So cos cubed x is equal to, so cos x is equal to 1 over the cube root of 3. Just positive, right? It's a cube root. Okay. If it's a square root, then it's plus or minus, right? If it's a fourth root, it's plus or minus. But if it's a cube root, it's just plus.
How do you rationalize this number?
Why would you want to? But how? You multiply by the cube root of 9. So that'll give you the cube root of 27, which is 3. Okay. So when you're rationalizing a cube root, you have to get a perfect cube. Okay. So a square root, it's easy. You just multiply by the same thing. But for a cube root, if I want to rationalize that, I multiply by the cube root of 9, top and bottom. So it becomes cube root 9 over cube root 27, which is cube root 9 over 3. Okay. But that's how you rationalize a cube root. Which we don't have to do, right? So this is quadrant 1 and 4. Quadrant 1 and 4. What's x? X ref is the inverse cosine of 1 over cube root 3. In degrees, right? Mode, degrees, inverse 1 divided by, so you can find the cube root in math number 4, right? So 1 divided by cube root 3, 46 degrees. And if you had rationalized it, right, what did I say it would be? It's cube root 9. Where's cube root math? Cube root 9 divided by 3. Okay. Easy. Hard and likely you made a mistake getting this. Just do it on this, right? We don't care. We're not. If our answer was 1 over cube root 3, then yes, you should probably rationalize it. But it's an intermediate step. Okay. So what did I say it was? 46 degrees. So what's x? And what? 314. Okay, and use whatever aids you need to. If you need to draw it out in quadrant 1 and that and figure out the angles, okay, by all means. That's it. Trig, done. Done. When did we start? What was the first day of trig? Monday, October 5th to, only a month, Friday, November 6th. That's only a month.
Feels longer.